Hey there, chemistry. Little like impromptu video here because I wanted to sneak in one more grade for the end of the marking period. So I'm sorry this video is going up kind of late. Um, but I just really wanted to get this in before the end of fifth marking period. So here we go. If you need a little time, if you need until like Sunday to get the lab in, I get it. I'll send out an email to everybody to like remind people. Also, please check, like just as a generic statement, please check my CBA, make sure that everything is in. Um, this lab here is a boiling point elevation lab. It's based on a concept we haven't exactly talked about. Fully remote students might have already watched the notes for boiling point elevation because they're in solutions, but anyone who kind of like who is in class normally, y'all wouldn't have this yet. But I'm going to use it to like intro what happens, right? Why boiling point elevation happens. So one thing that I noticed, this is not right. This is the wrong amount of sugar. I shouldn't have erased all of that. Just like it's not 34.2. It's actually 18 grams of sugar, and there's a reason for that. But it's 18 grams of sugar, and the three substances that we heated in the lab were like pure water, salt and water, and sugar and water, which shouldn't surprise anybody, right? When we did this in class, most people got a boiling point for water right around where it should be, which was 100 degrees Celsius. What folks found for salt and water, right, added 5.8 grams of salt, which is not a ton of salt, right? It's more than a pinch, but less than a teaspoon. I think it's less than a teaspoon. Pretty sure it's more than a pinch though. But 5.8 grams of salt was not a ton. So measured out 5.8 grams of salt, poured it into 100 milliliters of water, stirred it around, threw it on top of the Bunsen burner, and boiled it. And there's an interesting thing. Some people have been told that putting salt in water reduces the boiling point and makes it boil faster. Neither of those things are true, but more on that in a moment. What ended up happening was the boiling point for a few groups, and I think this was, I'm taking the high mark here, but this was the high mark for salt and water. It's about 104.5. So just adding 5.8 grams of water, which again, a little more than a pinch, and this is to a little itty bitty, 100 milliliters of water is also not that much. But it raised it 4.5 degrees, which is almost like 5%. Doesn't feel like a lot, but that's quite a bit. It got the boiling point elevated, right? It elevated quite a bit. So people thought, based on the fact that it was 5.8 grams of salt but 18 grams of water, all right, if salt and water went up 4.5 degrees, sugar and water should go up even more than that. And that was also wrong. We found that I think the high mark for sugar and water was only about 102.1 degrees. And just seems weird, this seems strange. It should. Because you added, or, we added more than 3 times as much sugar. 18 grams versus 5.8, right? 3 times as much would have been 16.8, so 18 grams. Added 3.1 times as much sugar as we had salt, and somehow the temperature still didn't change as much. It almost changed. It changed actually less than half as much for the high mark. And this is odd. It all dissolved, right? All the sugar dissolved, all the salt dissolved, so it wasn't a matter of like not having enough water to deal with what we were dissolving. It was just the sugar didn't raise the boiling point as much. Right? So when we talked about the questions, what boiled at a higher temperature, water or the solution? Well, this is either solution, right? The solution did. Water or the sugar solution? This was the sugar by far. Water or salt? This was the salt, right? Those 3 questions are very straightforward. The other 2 questions here are a little less straightforward. There's a little more, and again, I don't know why the separation happens the way that it did. But which boiling point was higher, the salt or the sugar? For number 4, salt water was higher. And why were they not the same even though there were 0.1 moles? Okay. So, ooh, yeah, okay, good. 0.1 moles. It was 5.8 grams of salt. It was 18 grams of sugar. Right. And again, 0.1 moles. Moles is, it's been a while since we talked about moles. But 1 mole of any substance is considered like the same. And when I say the same, it's the same number of particles. So remember that a mole is like a dozen, right? A dozen is 12 things. A mole is 6.02 times 10 to the 23rd particles of a substance. Or it equals the GFM of the substance, right? So if I'm counting, if I was to count 1, 2, 3, 4, whatever, it would be 6.02 times 10 to the 23rd particles. If I was taking the mass, if I was weighing it, then it would be the GFM. Salt, or NaCl, has a GFM of 58. Sugar, which is C6H12O6, has a GFM of 180. Right, so all I did was I moved it over by 1, moved the decimal place over by 1, so instead of 1 mole, I have 0.1 mole. They weren't the same, even though they were both the same number of particles. Right, they were both 6.02 times 10 to the 23rd, well, actually, 0.1, 10% of that, so 6.02 times 10 to the 22nd. But anyway, it was 6.02 times 10 to the 22nd particles, so it was the same number of particles. But the thing is, sugar, when it dissolves, stays as one particle. It's one giant monstrous particle. C6H12O6, as far as particles go, is very big. NaCl is fairly small, but when NaCl dissolves in water, it splits. It splits into Na plus and Cl minus. And the reason that's important is because now it acts like it's two things. So it acts like, instead of being 0.1 mole, it acts like it's 0.2 moles. So salt water raises the boiling point more. This is because salt splits or separates into two particles. When it dissolves. So because there are twice as many things, twice as many particles floating around in the water, it makes it harder for the heat to get to water particles. Right? When you dissolve something in water, that means something else is floating around in there. When it was only water, the flame was able to heat only water particles. When we start adding other stuff into water, now the heat has to add energy to water particles and other stuff. So it becomes more difficult to get the water to boil, for the water to have enough energy to turn into a gas. Alright. Finally, number 5. Why did the moles of substance have to be the same but not the mass? Moles... for this comparison, right, conceptually, moles is a measurement of... Moles is a number of particles. It's a measurement of the number, how much you have of something. We want the number of particles that's in there to be the same, not necessarily the mass, because if you want to measure what the effect is on this, we can't just have be... trying to think of like a comparison here. A pound of apples and a pound of watermelons is not going to be the same amount of each, right? A pound of apples might be like 7 or 8 apples. A pound of watermelons might just be 1 watermelon. So that's not a super fair comparison if we're trying to find how these things... And that's like salt, it would be like the apples. The watermelon would be like sugar, just size-wise. Again, look at the size here. 58 grams versus 180. So this 180, the sugar is almost 4 times as big. 3.5 times as big as the... oh no, 3 times. It's 3 times as big as the salt. So 1 sugar particle has the same mass as like 3 salt particles. But we're not trying to figure out what the effect of the mass is. We're trying to figure out what the effect of the particle is. So the reason we have to do moles instead of mass is moles is a measurement of the number of particles of a substance. And that is the concept we're trying to test. How does the number of particles of a substance affect the boiling point of a solution? Not necessarily how does the mass of the substance affect it. And again, this goes back to the notes, which if you're in class, we will talk more about on Monday. If you're hybrid, if you're fully remote, you might have already checked out the notes on... Where did they go? Where did my notes go? There they are. You might have already checked out the notes here. This is this part. When a solute is dissolved in a solvent, the particles of the solute have an effect. Right? It's about how many particles there are. It's not about the mass of the particles, it's about how many there are. So that's why we needed the number of moles to be the same. Anyway, this lab... Where did it go? There it is. The boiling point elevation lab. This was the last one that I want to put on to 5th marking period. 6th marking period, we will finish up the last 4 topics: solutions, acids, bases, nuclear chemistry, and organic. I probably won't do it in that order. I do want to do nuclear chemistry first. I think it's... But we'll get to all of them. Yeah. That's where we are. Fully remote students, there will be another video this week for a few more labs. I'll probably start doing a bunch of labs in advance too, so you'll have access to all the videos before the assignments go up. That way you're not behind like you have been. Now that I know kind of where we're gonna be with the notes, because again, you saw it up there. I've got solutions and nuclear chemistry done. I'll post a video for acids, bases, and organic chemistry. So I'll post a notes video. It might just be a super long, like 1.5 hour long video that has everything, but we'll get there. If you have questions, email me. If you need to take until Sunday to like actually get all this done because you have stuff going on, like just know that the video is up. All right. Until next time, kids. I will see you. Be good.